Yeah, good morning everyone. Welcome to session Success Mantra. What today we are going to discussion about anti-aromatic compounds. What is anti-aromaticity? Okay. Yeah, number one point is the planar and cyclic must and should planar and cyclic. Each atom shows the sp2 hybridization. Okay. In the hybridization, the formula is the number of sigma bonds with lone pair of electrons. I'm sure. Yeah. Okay. Yeah. And another important point is it's follow the 4 and pi rule. Okay, that is the aromatic compounds. It's follow the 4 and plus 2 pi rule. That is the Huckel's rule. It's the anti-aromatic compound. It's follow the 4 and pi rule. N value is equal to 1, 2. We have to take 1, 2, 3, 4, 5 like that. Okay, 4 into 1. That is the 4 pi electrons, and 4 into 2, 8 pi electrons. That is 4 into 3, 12 pi electron, 4 into 4, 16 pi electrons will be like that. Okay, it is a 4 and pi electron rule. Which compound is follow the 4 and pi electron rule? That compound shows the anti-aromatic property. Okay, I'm showing the good example. It is I'm showing the good important example. It is good and important example. Heterocyclic compound. Here the boron is there. Here it is a empty orbital. It is showing the sp2 hybridization. Number of sigma bonds is the borons 1. This is 2. This is 3. Okay, number of sigma bonds is 3. S, 1 is S and 2 is P. P1, P2. Yes, sp2 hybridization. It's follow the sp2 hybridization. And how many? This is a cyclic and planar compound. How many pi bonds is there? Number 1 and 2 pi bonds is there. 2 pi bonds, it shows the 4 pi electrons. Okay, 2 pi bonds means it shows the 4 pi electron. 4 into 2, 4 into 1, that is a 4 pi electrons. Okay, it is an anti-aromatic compound. And here, what is showing is aromatic compounds means the compound must and should be cyclic and planar. Okay, that is all carbon atom have the same hybridization. All what I am showing here, the carbon atoms. Most of the times, the compounds are the organic compounds. Okay, most of the time the compounds are the organic compounds. That's why we are always using as a carbon atoms. Okay, yeah, carbon atoms. In a compound mustn't be cyclic and planar. The atoms, all atoms have the same state of hybridization. Okay, all atoms show the sp2 hybridization. That is the 4 pi rule. Okay, it's follow the 4 pi rule. That compound is showing the anti-aromatic property. Okay, anti-aromatic property. Let's see the examples. Cyclopropenyl anion. Okay, cyclopropenyl anion. It's having how many pi bonds is there? One pi bonds is there, and one negative charge is there. Yeah, one pi bond, one negative charge is one pi bond plus one lone pair. Negative charge means it's containing the lone pair of electrons, two electrons. So there is a 4 pi electrons rule. It's follow the 4 pi electrons rule, which is anti-aromatic. And another one example is a cyclobutadiene, that is called as a 4-aniline. Okay, this is showing up 2 pi bonds. Okay, 2 plus 2. How many electrons is there? 4 pi electrons. So it is this, each atom is showing the sp2 hybridization or not? Yes, it is showing as a sp2 hybridization. Each atom. Okay, this is sp2, 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 sp2. Yes, each atom is showing the sp2 hybridization. And another one good example is cyclopentadienyl cation. Okay, this is having the 2 pi bonds is there. This is a positive which is there, and it's showing the sp2 hybridization. Okay, sp2 hybridization. Each atom is showing the sp2 hybridization. That is a 4 pi electron. And same as this cyclooctatetraene also, it is having the 4 pi bonds and 8 pi electrons. It is also showing the anti-aromatic property. And another one good example is 12 aniline. Okay, how many pi bonds are there? Here in this one, 1, 2, 3, 4, 5, and 6. Okay, 5 and 6. 6 into 2. 6, 6 into 2. That is 12 pi electrons. Okay. That is 12 pi electrons. So 12 pi electrons is there. 4 into 3. Directly we will get the 12 pi electrons. That is a 4 and pi rule is following is or not? Yes, it is following. It is following the 4n pi rule. 4n pi rule. When n is substituted as a 3 value, we will get the 12 pi electrons. So 12 pi electrons, that is called as a 12 aniline. Okay, here the showing as a 12 means it is the number of electrons. Okay, 12 aniline. 12 aniline is a anti-aromatic property. Shows the anti-aromatic property. Same as it is good. Another one good example is 16 aniline. Okay, 16 aniline. 4 into 4. 4 into 4. That is equal to 16 pi electrons. Okay, 16 pi electrons, showing the 16 pi electrons, and each same properties. There is no change in the properties for the aromatic and anti-aromatic, but the principle is changed. It's follow the 4 and pi rule. It's follow the 4 and pi rule. Cyclic, this compound must be cyclic. Must and should be cyclic, and each atom is showing the sp2 hybridization. Look at once here, each atom is showing the sp2 hybrid. This is the sp2 hybrid. Double bond is there. It is sp2 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 hybridization, and each atom is showing as the same hybridization in that molecule. Same hybridization in that molecule. It should be planar. The compound shows the anti-aromatic property, which is follow the 4n, which compound is follow the 4n pi electron rule. It's follow the 4n pi electron rule. 4n pi electron rule. It's follow the 4n pi electron rule. Each atom is showing as a sp2 hybridization, same hybridization. It is a cyclic compound and it is a planar compound. It is a cyclic compound and it is a planar compound. So 16 aniline. 16 means how many electrons is there? 16 pi electrons is there. 16 pi electrons there. 16 aniline is showing as a anti-aromatic property. It's very simple. How many pi bonds is there? 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8 to the 16. Okay, 8 to the 16. 16 pi electrons. 16 aniline showing is it is a cyclic compound or not? Yes, it is a cyclic compound. Okay, each pi bond is showing a, yes, each atom is showing the sp2 hybridization. So it is a 16 aniline showing as a anti-aromatic property. It is a good example. Here the question is asking the which one is showing as anti-aromatic property given below. It is 16 aniline and 18 aniline and 14 aniline and 12 aniline and 10 aniline. They will be like this. A and B, A and C, A and D will be like that. Given is a question in like that way in the asking the examination. Nowadays, they are not asking in the simple questions like this, which is aromatic compound, which is a non-aromatic compound, which is an anti-aromatic compound, will be like that. Minimum, they are giving the total concept orientation questions now given in the examinations. Okay. Here the sum of the example. Okay, it is showing as anti-aromatic property here. Yes, it is showing as a anti-aromatic property here. Okay, showing as an anti-aromatic property. Yes, it is showing as a, how many pi electrons is there? One, two, one. Okay, involving there is one, two, three, four. Okay, four means four to the eight pi electrons. So it's showing as a anti-aromatic property. Yeah. Like this question will be asking in the examination. Now, which compound is that is anti-aromatic compound? Yes, given below. You can look at what's here. Which one is the anti-aromatic property? It's showing as anti-aromatic property. Here, the example is already asked in the examination. Okay, previous question is the compound is that is the anti-aromatic. Which one is the anti-aromatic compound? It is okay. Yeah, this type of questions will be asked in the examination property. Yeah, okay. Okay, this is already we are discussion about this question. Okay, this is a aromatic property. Sorry, anti-aromatic property.